Guys, this is the first day of fractions. I want to make sure you guys understand what fractions are without using pencil and paper. How to solve an operation of fractions without using pencil and paper. You guys can relax. I know we're being recorded, but just relax. This is what's going to guide us. This is our first standard of our fractions unit, which is Unit 4, MCC 5, NF1. Okay? Numbers and operations with fractions. The first standard that we're going to really look at is this one that deals with adding and subtracting fractions with unlike denominators. So, Esteban, can you read the standard for us, please?
I MCC 5 I can add and subtract fractions unlike denominators, including mixed numbers, replacing given fractions with equivalent fractions.
Okay, so we're going to replace given fractions with equivalent fractions. But guess what? Before we do any of this, I want you guys to understand what a fraction is and how we actually solve them without using pencil and paper. I want you to understand the concept of a fraction first, okay? So if you look at the model that you have set up already, if you look at your model, you have what type of array is this? What type of array? Remember that word array from 4th grade, 3rd grade. What is an array?
Array is when you have a number going in top row and a number going by the bottom, and you can multiply it to figure out what's in the inside.
Good, and that'll tell you the total amount that you have. Okay, so in this case, what type of array do we have? What are the numbers?
A 3 by 3.
3 by 3 array. All right, so obviously you guys learned this before from repeated addition and also multiplication. What is 3 times 3?
9.
9. So if you look at your model, how many green pieces do you have?
9.
You have 9 pieces, exactly. So we can say that. Now listen to listen to these words. Listen to the terminology. If you have 9 total pieces, that is your denominator. That is the total number of parts that you have. So on the count of 3, I need you to grab your pencil. 1, 2, 3, grab your pencil. On your sheet of paper that you have, I want you to write down the word denominator. D-E-N-O-M I-N-A-T-O-R. Okay? So if you write the word denominator on your page, that is the word that represents the number that's in the bottom. Okay? But we're not going to use the word bottom anymore because the top number and the bottom number have specific names. Okay? What do we say is the name for the bottom number?
Denominator.
What number is in the denominator with this model?
9.
Okay? So what number would be in the top if we have
3.
3? Are you sure?
Yes.
Okay. So if you say that there are 3 ninths, are you saying that there are 3 total green pieces out of 9? Or are there 9 total pieces?
There's 9 total pieces.
So there's a misconception. Remember I talked to you guys about misconceptions in the previous lessons. I think you guys are saying 3 out of 9 because there's 3 in each group?
Yeah.
And there's 9 total pieces. Okay? What if I told you that 3 is 1/3 of 9? Can you look at your model and tell me how 1/3 of 9 is 3? Jayla. 1/3 of 9 equals 3. Actually, everybody write that down. 1/3 of 9 equals 3. And I want you to write these words. But how? But how? With a question mark. And I want you to take a couple of seconds to. Right now, we're in the process of clearing up a misconception. Okay? Do you have a question? Okay. We're going to clear up a misconception because I don't want you to think that 3 ninths is representing our model. So think about how you can see that 1/3 of 9 equals something. What is that something going to be, Jaquim?
1/3 of 9 equals 3 because it's like this is 1/3, this is 1/3, this is 1/3, and then if you add 1 plus 1 plus 1 equals 3, so you don't add your denominators, you add your numerators, and your denominators stay the same. So that's why it equals 3.
Do you all agree with that? If you agree with Jakim, you're absolutely correct. Is there anything you wanted to say, Jayla, that goes with this? Because I think now the misconception may have been cleared up. But explain what Jakim said if you want to add something to that, Jayla.
I want to add if it's three on the one on the top, and you have to add it 3 times. 1, 2, 3. And it would be 3 over 3, which would equal 1 whole.
1 whole, okay. So, Safia, can you tell me how many groups we have? Tell me about the groups that you may see.
I see 3 groups of 3.
Okay. Now, what if I asked you all, this is what I want you guys to do. I want you to pick up, since Jakim, Jayla, and Safia let us know that we have 3 groups, and we understand that 3 out of 9 is 1/3. I need you all to pick up 1/3 of your pieces. Pick up 1/3 in your hand. Pick up 1/3. Be very confident in yourself. Pick up 1/3. Okay, so how many pieces do you have in your hand?
3.
We have 3. So somebody explain to me how what we've just done, what we picked up, and what Jakim said are basically the same. Savinia, I want to hear from you.
He said that 1/3 and 1/3 and 1/3 of 9 equals 3. Because he said this row is 1/3, this row is 1/3.
And so if you picked up 1/3, you pick up everything that's in that group. And how many pieces were in that group? 3. So is it safe to say that 1/3 of 9 is 3?
Yes.
Okay, so now I need somebody to think about how you can add or what did we just do? Did we add or subtract? What did we do? We subtracted or did we add?
Subtract.
Explain how we subtracted just now. And then tell me what I need you guys to do. If you all agree that we subtracted, if you agree that we subtracted just now by picking up 1/3 out of the whole group, raise your hand. Okay, so what I need you to do before you use any more verbal, before you explain anything else to me, put your hands down and explain to me or justify your thinking. Why do you think that we just did a subtraction problem by picking up 1/3? Write it down. And I look forward to reading your responses. Second. All right, are we ready? Okay, let's start with Safia. I want you to read your explanation.
I think we did a subtraction probably by 1/3 to show that each row of 3 is 1/3 out of 1 whole.
Okay, great. 1/3 out of 1 whole, great. And how many did you have left over?
Now we have 2/3.
Good. Go ahead.
We did a subtraction problem because we had a group of 9 before we took away these and took away 3. So when you take away something, you basically subtract it.
Excellent job. Jayla?
I think we subtracted because you're taking away from the 9, so 1/3 of 9 would be less.
Good job. Excellent, excellent so far. Go ahead, Jakim.
The reason I think we subtracted is because we picked up 1/3 of 9, which is the whole thing.
Okay, and how many did we end up with? How many thirds were left?
2.
2/3. Yeah, be very confident. You guys, when you respond, I want you to sound very confident. Okay? Even if you may be incorrect, if I tell you that it wasn't quite accurate, still be confident because I can help correct it. Okay? All right, Savinia.
I think we subtracted because 1/3 is 3, and we took away 1/3 away from our array.
Good, good. You took away 1/3 and you were left with how many?
2/3.
Good. And Esteban?
I think we subtracted because we picked 1/3 out of the whole.
You put 1/3 out of the whole. Everything you guys said was accurate. Give yourself a silent round of applause. Okay? Now, based on what you have left here, this standard says that we're going to replace a given fraction with an equivalent fraction. But before we do that, I want you to look here. Isn't this what we started with?
Yes, sir.
3/3. And we picked up how many?
1/3.
And how many were we left with?
2/3.
Did you guys have to use a pencil and paper to do that? No. That means concept. You have the concept. You understand what we're doing without having to use paper and pencil. That's the whole goal of this, okay? So if I give you 10 problems like this, you can now see, okay, if I have a common denominator and I'm subtracting, why don't I just take a group and subtract and I can see it better. I can visualize it. That's what I want you guys to do. But now I want you to see this in a different way. Keep that 1/3 separated. The 3 that you had, that you took away before. Now it says here, I want you to replace a given fraction with an equivalent fraction. So what does that mean? What else do you see here? How else can I look at my array and explain what I see in front of me? If you know that you have 9 total parts, let's use a different denominator now. We're done with the 3 denominator. What do we see now, Esteban?
9.
You see 9. 6 nines. Explain that.
Because there's 6 pieces and it's out of 9.
So how many did you pick up?
I picked 3.
3? So is that 3 nines? 3 nines. So if you take 9 nines and subtract 3 nines, how many nines are left?
6 9.
What did you want to say?
I wanted to say that 3 9 and 6 9 is equivalent.
You're absolutely correct. Joaquin, did you want to say anything? Okay. Think about what you said. Say it again. 3 nines and...
3 9 and 6 9 is equivalent.
Okay. I want you to think about that. 6 nines and 3 nines are not quite equivalent. But 1/3 and 3 nines may be equivalent. 1/3 and 3 nines. Okay? That may be another misconception. When we switch denominators, you really have to look at how many were in each group and look at the total number of larger groups, which is 3, right? But then we look at the smaller parts, the denominator changes. Okay? So is there any, as we wrap up, and we're going to get deeper into this over the next couple of weeks, but as we wrap this up, I want you guys to summarize. Think about how you can summarize what we've done. I'm going to go to each and every person to make sure you understand exactly what the standard is asking us and what we actually accomplished here with our models. All right? So think about it for about 10 seconds. And then I want you to think of it, a couple sentences that you can tell us about that summarizes what we've done. And you can start whenever you're ready. In no particular order. Okay?
What we did for this, what we did was we had to figure out how a fraction, but without using our pencil, and we had to figure out how many units we could do out of 1/3 out of 9. Why? Because it equals 3, and we figured out how it equals to 3 because we took away 1/3. We had 3 in our hand.
Excellent. Excellent. Go ahead.
We learned how to use fractions with a model instead of paper and pencil. And subtracting and we saw that each one is 1/3 or it can be 3 at remaining 1/3 of 1/3. And then we subtracted it and we got 2/3. After that we were finding different ways to give it a name instead of everything.
Okay, and they had a new name, which was what?
Which would be 3 9 or
1/3 is equal to.
1/3 is equal to 3/9.
Excellent. All right, Jayla.
We learned how to add and subtract fractions mentally and doing it with a model. We took away 1/3 of the 9, and it gave us 3.
Okay, good. And that's how you had 3. Exactly.
Okay, what we did was we talked about the misconceptions that we had with like 3 nights, and we figured out that it's really supposed to be 1/3, and then we figured out that 1/3 of 9 equals 3, and the reason why is because you took up 1/3, and you had 9 units, and you took up 1/3. So that's why you took 1/3 of 9. That's why it equals 3.
Good job. Excellent. Excellent.
What we did was we had to figure out the fraction without using paper and pencil. We did. We took away 1/3 of the fraction. And we just left 2/3. And we tried to figure out different ways to do the fraction. Well, the fraction that was left. 2/3.
Exactly. Good job. And Esteban.
We did we used a model to find stuff because we had saw first that we had 9 out of 9, and then we saw 1/3, and we took out and we found that 3 out of 9 and 1/3 is equivalent because we took away 3. We took 1/3 and we took 3 pieces of ham.
Excellent. I'm really proud of you guys. Did you learn something?
Yes.
Yes?
Yes.
All right. Let's put it in. Ice cubes on the count of 3. 1, 2, 3.
Ice cubes!